Hey everyone, welcome to my channel. This video is one of the videos that I'll be posting to help you learn math. In this video, you will learn about solving problems involving parallelograms, trapezoids, and kites. So let's get started. Let's proceed to number 1. Given the parallelogram below with indicated measures of its sides, solve for the values of x and y. Also, solve for the perimeter. So we know that this is parallelogram ABCD. So we also know that a parallelogram is composed of two pairs of parallel sides. So we can see that AB, or segment AB, is parallel to segment DC. Also, we can say that AD is parallel to BC. Aside from their parallel, these two pairs are also congruent. With that being said, we can say that 10y minus 8, which is actually the measure of AB, is congruent to 7y plus 1 or DC. So as an equation, we have 10y minus 8 is equal to 7y plus 1. We have to equate it like this so that we can solve for the value of y. And afterwards, we can solve for the values of AB and DC. So using the property of equality, we can just simply say we transpose or put 7y on the other side along with 10y. And we put negative 8 on the other side along with 1. So always remember, in property of equality, if we're moving one term on the other side from one place to another, so that means we also change the sign. So from positive 7y it becomes negative 7y, and from negative 8 it becomes positive 8 this time. So 10y minus 7y is equal to 3y, and 1 plus 8 is equal to 9. So again, using the property of equality, we divide both sides by 3 so that we can get y, which is equal to 3. With that being said, we can now solve for AB, represented by 10y minus 8. Using substitution, we can now substitute for y, which is equal to 3, as we solved earlier. So we now have 10 times 3, 30 minus 8, and that is 22. We can now say that segment AB is 22. Same thing with DC. So we assume that, or we expect that AB is 22, so DC should also be 22. So let's try to check that. So 7y plus 1. So again, substitution, we have 7 times 3, one that we were able to solve earlier, plus 1. So 7 times 3 is 21 plus 1. So that is again 22. So again, segment DC is 22. Alright, let's proceed to AD and BC. So again, AD is parallel and congruent to BC. So with that, we'll have an equation 6x minus 1, this one, which should be equal to 5x plus 1. There. So again, property of equality, we'll have 6x minus 5x. So we transpose, or we put this on the other side along with 6x. And 1 here, this negative 1 becomes positive 1 on the other side. So this is 6x minus 5x, which is x. And 1 plus 1 is 2. So again, we can now solve for AD using substitution. So 6 times the value of x, which is 2, as we solved earlier. So 6 times 2 is 12 minus 1, which is 11. So we will have AD, which is equal to 11. And again, we should also expect that BC should also be equal to 11. But again, you can check that. So that's 5x plus 1. So 5 times the value of x, which is 2, as we solved earlier, plus 1. So 5 times 2 is 10, plus 1 is 11. So again, BC is 11. So there you go. That's our first problem. So let's proceed to the next problem. Given QRST is a parallelogram with the indicated measures of the sides and angles, find the values of x and y. So again, just like the parallelogram earlier, we can just simply say that this side QR, okay, is parallel and congruent to TS. So again, by using an equation, we'll have x squared plus 5 equals 54. So in this case, we'll have x squared, and we isolate it so that we can put together 54 and 5, which are both just numbers. So 54, and then this becomes minus 5. So x squared equals 49. Again, property of equality, but this time we can just simply say we get the root or square root of both sides. So this becomes x equals 7, positive negative 7. But since we want the absolute value for both, because we're dealing with measures, so we can just say this should be positive 7. So we can now check using a substitution. We will then have QR, which is equal to x squared plus 5. By again using substitution, we'll have x, which is 7, then we square it, plus 5. 7 squared is 49, plus 5, which is equal to 54. So we just proved that QR and TS are both 54 after solving for the value of x, which is 7. So this is correct. Okay. Now we can also solve for y and these given angles. So for a parallelogram, we can say that the opposite angles are congruent. So that means this angle here is congruent to this angle here, and supposedly we still have another angle here which is also congruent to this angle here. Okay, so with that, angle R is congruent to angle T. So angle R is represented by x plus 15y degrees, and angle T is 127 degrees. So this time we can again apply the substitution method. Okay, so since we were able to solve for x earlier, which is 7, so we can substitute it here, and we will then have plus 15y equals 127. So again, property of equality, we put 7 on the other side along with 127, so it becomes negative 7. So 15y equals 120. So again, we divide both sides by, this should be 15. Okay. Oh, I'll just change it into 15. Oh, my bad. Okay, we zoom this out, and there you go. So this should be, okay, this should be 15. I'm sorry about that. Okay, so, and if we divide 120 by 15, so how many 15s do we have? So those who are having hard time, solving or dividing numbers, it's like this. Basically, you just have to find how many 15s are there in 120. Sorry, reset. Okay. So basically, you can just try with 10, but 100. 15 times 10 is 150. So we still have 30 exists there, so that means we'll have 8. I don't know what is happening here, but anyway, this should be 8. Okay, so you can try. So 15 times 8, it should be 5 times 0, then carry 4, so that's again. You can also solve for the two other angles. So we are expecting that angle R, should also be equal to 127, but that's only possible if we're going to be doing the checking. So we substitute x. So again, angle R should be equal to 127, just like angle T. So again, this is x plus 15y. Sorry. So x is 7, as we were able to solve earlier. And then 15 times y. Y is 8. So this is 7 plus, this is 120. And so 7 plus 120 is 127 degrees. So again, R is also 127 degrees. All right. So let me just go back to the previous slide earlier. I think I forgot to answer the last question. Hold on. Okay. So earlier, it was also asking to solve for the perimeter. So again, when we're getting the perimeter of a parallelogram or any polygon, we just have to add all the sides. So since AB is congruent to DC, so we can say that since AB is 22, this is also 22. So 22 here, 22 here. And then since AD is congruent and parallel to BC, and we know that BC is 11, so this should also be 11. So 22 plus 22 is 44, and then 11 plus 11 is 22. So 44 plus 22 is 66. So the perimeter of this one is 66. All right, there you go.